Hey everyone, it's Greg from the Laser Channel. Join me in this video as I do a first setup and calibration of the JICCODA rotary unit. Welcome back. To start out, I'd like to show you the contents of the box. There is, of course, the JICCODA rotary unit, an accessory wheel that fits to either side of the unit, an accessory bag with a couple basic tools and 3 sets of cables. One of those cables doesn't have the connector attached just yet. The cable does have the pins on the cable. This means that you can configure the pins in the connector to suit your specific machine if you're not using a JICCODA line of products. Also located inside of the box is the detailed manual that tells you all about the rotary unit, how to adjust the rollers, set the belt tension, and one last thing I'd like to show you is the foam packaging inside of the box. There's foam on the top, the sides, and the bottom. This front roller on the rotary accessory is completely adjustable for the width. To do this, simply loosen the belt tension knob here until there's slack on the belt, and then remove these 2 orange screws on the outside of the unit. This roller is now available to move back and forth to suit whatever material you're going to place on the rotary unit. Replace the screws on the end. And gently apply tension using this particular knob. It's as easy as that. All the parts are contained here, and there's no tools needed to make any adjustments on the rotary attachment. As I mentioned before, it does have this accessory wheel. There are rows of holes on here, and those holes line up with pegs on both sides of the base of the frame. This allows this to be positioned back and forth and also in and out. It's a really neat way to set this up to place the wheel and not have it shift around while you're making adjustments on this or placing material on top of the rotary attachment. Jumping right into things, the materials needed for setting up and calibrating the rotary attachment are a laser machine. For this video, I'm using the Jiccoda L1 machine. This particular machine has the 10-watt laser module on it. If I move this back, you'll see that I have the orange shroud removed off the end of the laser module because I have fitted the Air Assist kit. I'm going to put this off to the side because the first thing that I like to do before placing the laser machine on the table is to protect the table from any stray laser waves in case the laser misses the rotary attachment because I told it to go somewhere where it shouldn't. For that, I'm going to use the aluminum backer board that comes with a Honeycomb kit. And a little tip that I like to do is sometimes this aluminum can slip and slide around on the table a little bit, so some blue painter's tape keeps that secured on the table. I'm now ready to place the laser machine over the top of that. We'll need something to stand the machine up off the table so it has clearance for the rotary attachment underneath. For that, I will be using 4 pint glasses that I picked up from the Dollar Tree. And those glasses, when they're placed on the tabletop, I'll have the bottom of the glass facing upwards, and then the 4 feet of the laser module will sit on each of these glasses. Now, initially when I read this in the instructions, I thought it was a little bit odd, but JICCODA is really marketing this rotary unit to go on many machines of the market, and they don't necessarily know what type of standoffs are needed. To align the rotary attachment to the machine, I like to use a flat board. I have this board from a previous project, and I'll show you what I do with this in just a short little bit. Continuing on to do the calibration of the rotary attachment to the machine, I'll need a glass jar that has perfectly flat sides on that. For this, I'm going to use an old jam jar. The one I happened to grab actually has a little bump out on the top and the bottom, and this I had set aside as an example of the kind of jar that we don't want to use. We want to have completely flat sides. And when I reach down here and grab the correct one, this particular jam jar has no indents on it and is perfectly flat along the sides. And I'll also need a roll of blue painter's tape. This is everything that we need for the project. Off camera, I placed the machine on top of these pint glasses. It's a nice stable platform. I've used this before with this setup and I have not had any problems. To start out with, I'm going to place the rotary unit inside of the machine. Before I do that, I'm going to grab the cable with the black ends and plug that into the connector port on the back of the unit. I'll place this somewhere around the middle of the workspace of the laser machine. Next up is to square the rotary unit to the machine, and for that, this is where I grab the flat project board. I'll move the laser module off to the side, and what I'm going to do is use this axis frame to square up the rotary unit. For this, I'm going to place the board against this back frame here and move the gantry forward carefully until it gets very close to the back of the rotary attachment. From there, I will look down the top and make any small little adjustments until it's perfectly squared up. I like this method. It works perfect for me. I've never had any problems, but choose for yourself what method best works for you. If I was turning a piece of material that was tapered or a wine glass that had the stem of the glass where I would be using this auxiliary wheel set, I would place that in the appropriate spot underneath the rotary attachment first before squaring it up. I like to touch and handle the rotary unit and have that all set up, the wheel space all adjusted before doing the final squaring up to the machine. And the last thing to do here is to connect the other end of this cable up to the wiring harness of the machine. Now this method that JICCODA uses is used by virtually all of the other manufacturers, and that is they disconnect the wiring harnesses for the motors that move the gantry in this direction, and they plug this connector into that. This particular machine has a drive motor in the front corners on both sides. I'll unplug both of those, and my tendency is, because the connector comes out on this side from the rotary attachment, this is the corner that I'll plug this connector to. That's one connector removed, and the other connector removed. With that simple plug, it's all set to go. I have connected the power cable up to the laser machine along with the USB cable up to my computer. I have LightBurn running, and I'm going to drop down the menu and pick the Jiccoda L1 machine. I still have power off on the laser machine, and I want to show you something that kind of threw me for a loop when I first started using this. I want to zoom in on the corner of the homing spot. When I powered up the machine, or when I started the software, it put this special little crosshair in the corner of the work area. The software thinks that the laser module head is already in the home position. So before I turn power on the laser machine, I want to just move this head over to this side. It doesn't have to be on that limit switch. It can be off a little bit. This direction, back and forth, doesn't matter because we have that cable disconnected. That's where the rotary attachment is plugged in. I'm ready to turn the power on. And I'll connect. And it is ready. In LightBurn, there's a spot here where you can have a rotary enable button. Mine's not showing up, so I'm going to navigate to Edit, Settings, and there's a little checkbox, Show Rotary Enable on Main Window. I'll check that, and now that pops up. I can navigate to the top here for the rotary setup. When I click on that, this is where all of our calibration is going to take place. we only need to do this once. Here's a quick explanation of the things in this submenu. The chuck type is if you have jaws that are going to clamp down on your piece of work. We don't have that. We have this roller type. I call it the hot dog rollers. So that is currently checked. I did enable the rotary on the main menu. We just added that button in. On this particular setup, I do not need to mirror the output to the rotary. I want the rotary axis connected to the y-axis. Again, that's where this cable that comes with the rotary, that's where that's plugged into. And here I'm going to skip over this one for now and move down to the roller diameter. That roller diameter is the diameter of these rubber covered drive rolls. And I've got a dial caliper here, and I'm going to just take a quick measurement of that. And I read that I do have 0.796 inches. This top number now is the number that is going to be adjusted when we tell our test jar to rotate a certain distance. This is the area that will make that adjustment to make sure that when we tell LightBurn to index 2 inches on this jar, that the machine properly indexes 2 inches. This area down below the object diameter and the circumference, just as the description describes here, it's just a calculator, but it's very, very handy. And in fact, we're going to use that right now. For this, I'm going to measure the diameter of my jar in several different spots. And you'll find when you start working with these cast glass jars or bottles that they're very seldom perfectly round. They're usually oblonged a little bit. So kind of get the average of that diameter. And my diameter is 2.724 inches, just as I have in here from when I first initially did the setup off camera. I can maybe make a super small adjustment so that you can see that bottom number change for the circumference. And I have 8.551 inches. That's a number that we want to jot down or remember in just a minute here. Everything so far looks good. I'm going to purposely change this upper number here so I can show you what that will look like when your calibration is off just a little bit. With that set, I hit OK. It's now time to use that blue painter's tape. I'm going to peel off a very large section of this tape. And somewhere around the middle of the jar, I want to just wrap this piece of tape. It's okay if there's a wrinkle on it, hopefully not too many wrinkles, and it can overlap ever so slightly. I'm going to go all the way around with my finger and make sure all that tape is, ironed down. And I can place that inside of the machine. This is the part where I can navigate to the Move tab, and I can use this little console here and manually index the laser module over the top of the workpiece. And again, because we have this motor disconnected, I'll be pushing this by hand, but this direction, we'll use the software to index that over. While I'm moving that, we'll see that this red crosshairs starts moving up towards the green dot that's in the center of the screen. And as we do that, the rotary accessory is moving, and it should do that. That is a good thing. That looks good, and now I'm going to manually index the laser module over the glass. And it's very clear now on the screen that this small red crosshairs is indexing over. It's a good thing to note that I had the start from set at the current position. This is what I want to have it set at when I'm working with the rotary unit. Now I have the crosshairs. I'll move that over just a little bit more. Generally, somewhere about in the middle of the work area is a good place to start. I'm going to draw a quick box here and show you a couple quick little things. I'm going to move the job origin from the 12 o'clock position to the 9 o'clock position, and it moved that little green dot over to the side. That's because when placing objects on the rotary unit, the opening of that glass faces towards the 9 o'clock position. So I just like to have the job origin and the opening of that glass facing the same direction on the clock. I can hit frame and the machine will go through framing that out. So it's good. We've got movement on everything. That's looking good. I've had so many times I left this red cursor in the bottom corner here and tried framing something out or starting a project, and LightBurn would throw errors, and it took me a little bit to figure that out. And the software was doing everything that I was telling it to do, but it was throwing warnings out and not allowing me to move it. So my best practice has been to move this little red cursor somewhere in the middle of the work area and make sure that whatever I draw for graphics, that it can draw everything out without it thinking that it's going to go out of bounds. So with that little tip covered, I'm going to draw a calibration bar. And this was a tip that one of the users had contacted me about from one of the other videos. A lot of the standard calibrations that the manufacturer suggests doing is drawing a 30 millimeter by 30 millimeter box and adjusting the rotary setup to make sure that it is a perfect square. And I've had a number of users contact me, and their method is that they'll draw a long box that goes all the way around the glass, and they want the ends of that box to line up perfectly. And it's actually, when I thought about it, it's a really great way to do that to get the most accuracy. And it's really beneficial for people that have particularly tumblers where they want to engrave all the way around the tumbler. For me, I do a lot of tapered glassware that is just across the front face, so that accuracy isn't needed, but I know for some of you, you may want to do engraving all the way around, and this is the best method that I know of that will get you there. So I'm going to uncheck this box. I'm going to make the width of that bar 0.2 inches, and I'm going to make the height 8.551. And again, that 8.551 is that number that was calculated over here under the circumference. Now you can spend as little or as much time as you would like in this area calibrating your rotary attachment up with the software. Here I'm going to change the job origin to the 9 o'clock position. Again, if I have it at the 12 o'clock, this is what the software is going to see. Okay, there, I grabbed it. If I put the job origin up to where the software thinks the laser is, I'll see that part of it goes out of bounds, and this might throw that error code. So I'm going to place this back up in this area and click the job origin to go to the 9 o'clock. And now we'll see that it's pretty close, and it should be able to frame all of this out and not throw that error code. And that all looks very good. Okay, I'm going to set the focus on the laser and come over to cuts and layers, and I only want to engrave just the tape. I don't want to go through the tape. So referencing my journal book that I have, I know a speed of, I believe it's 40 millimeters per second at a power of 15 will engrave just the tape. And in fact, I think I can bump the speed up to 40 millimeters per second if I remember a correction that I made in my journal book for run settings. The other thing that I'd like to do is manually move the laser to the 12 o'clock position over the glass jar. And this is what I mean by the 12 o'clock position. I just want to have the laser nozzle at the highest point of the glass to make sure that the focus is kept in. I should be all set. I set the focus, I did a test frame, everything looks good so far, and I'm ready to start. Here's that close-up, and we'll see that the calibration is off a little bit. The two ends don't match up. So I'll place this back in the rotary attachment and I'll do one more pass with a different setting. When I place the glass back into the rotary attachment, there's no reason to retape the glass. I'll just position the glass over a part of the tape that hasn't been marked yet. To make the small adjustment, I'll navigate to the rotary setup button, and I'm going to change this to 62.75 and click OK. I'll get my glasses back on for this, and I'll hit start one more time. Where my thumb is was the first one that we did, and when I rotate this around, we're going to look at this upper one, and we'll see that it's virtually lined up perfectly, basically to the line width of the laser. And for me, that's going to work out just perfect. This is a quick and easy way to calibrate your rotary attachment to your laser machine for the first time use. Now in this example, I used the Jiccoda L1 series laser machine and rotary attachment, but this method holds true for virtually any of the laser machines on the market. I like the results I got with this calibration. I'm very confident now that when I have a design in LightBurn and I send it out to the laser, that everything will turn out correctly. It will all be scaled correctly from the computer down to the engraving on the glass. This is a quick and easy little setup that you'll only need to do once. Thank you for joining me in this video. I hope it really helped you out. If it did, I'd really appreciate it if you leave me a like, subscribe, or ring that notification bell for the next time a video comes out. Until next time, learn, create, and share.